Lesson 2, 2.2, Simplifying Radical Expressions. So yesterday we were simplifying single radicals, but what happens when we have radical expressions? So we need to think about a few properties. We're going to be talking about the multiplication and division property of radicals. So when we are talking about, and we as mathematicians like to keep it as vague as possible, as abstract as possible, so that we can apply this to anything. That means that you can fill in any number for n, any number for a, and any number for b. So the nth root of a times b is the same thing as the nth root of a times the nth root of b, where n is a natural number. Okay, so a natural number is anything that's 1, 2, 3, 4, 5, but we can't say that it's a natural number. We can't make it equal to 1 because there's no such thing as the first root. I guess that's itself. So and a and b are real numbers. So they can be fractions, they can be decimals, they can be negative, or they can be positive. And what I mean by this is we've been doing this the whole time. So if I were to say the square root of, say, 45, I'm going to say that's the same thing as the square root of 9 times 5, which is, this is where it is, the square root of 9 times the square root of 5. And we know how to simplify that. That's just 3 root 5. So recall from yesterday that 2 root 4, 2 root 4, right, which is a mixed radical. I'm pausing a little bit because the square root of 4 is actually 2, but we can write this as an entire radical. So what I need to do with the 2, I have 2 root 4. What do I need to do to the 2 to make it underneath the radical sign? Well, I'm going to say that the square root of 4 is the same thing as 2. Now I'm just going to highlight it to say that these two things are equivalent. Okay, and then I'm just going to do the remaining bit, root 4. I'm going to highlight that this is the same thing as this, which is simply the square root of 16. So this right here is our mixed radical, and this right here is our, oh, that was poorly done. There we go, is our entire radical. So, example number 1, let's arrange in order from greatest to least. So to do this, convert all mixed radicals into entire radicals. Now, sometimes that's very helpful. This is a very helpful hint, but there are certain circumstances where we don't have to worry about that. This one right here, it is helpful if we convert. Because then we can, because right now, 5 root 2 versus 2 root 5, you can't really compare them. It's like saying, if we would give this an x value, it's like 5 x's compared to 7 y's, right? Or, sorry, compared to 2 y's, just to make it similar. You don't know if one's bigger or which one's smaller. We need to kind of help them all speak the same language. And we need to get them all under the radical sign. All under radical. So if I were to look at 5 root 2, that's the same thing as the root of 25 times root 2, which is the same thing as the square root of 50. Because 5 and the square root of 25 are the same. What happens if I did 2 root 5? Well, that's the same thing as root 4 times root 5. 4 times 5 is 20, so we put it all under the radical sign. 20. 2 is the same thing as square root of 4. And this one, 4 root 3. In order to get 4 under the root, we square it. So we're going to say the square root of 16 is the same thing as 4 times the square root of 3. (16 times 3 is 48, so the square root of 48. So if I wanted to go from greatest to least, my greatest is going to be square root of 50. So this is our first one. Our next smallest is going to be, or next largest is going to be root of 48. And our smallest is going to be 20. Now we're not going to write, okay, root 50, then root 48, and then root 20. We're going to go back and answer with the original. So from from greatest to least, we're going to go 5 root 2, comma, 4 root 3, comma, 2 root 5. And I'm going to put a box around it so that I know that that is my final answer. This next one, I might change them all into entire radicals, but I'm noticing that this is all the same. So I'm just going to give kind of like a scenario. If I would have 9 x's, and if I would have 11 x's, and I would have 8 x's, I would say that 11x is the greatest, and then 9x, and then 8x. So we need to think of this as just simply a variable. So I have 9 of some quantity, and 11 of some quantity, and 8 of some quantity. And I know that 11 is the biggest. So when the roots, which mean the index and radicand, are the same, compare coefficients. So if I were to order this, I would say 11, the third root or cubed root of 2 is the greatest, then 9 times the cubed root of 2, and then 8 times the cubed root of 2. So I'm remaking this video because I apparently did not know how to use the calculator on the computer, but I think I have it all figured out now. So what I want to do is I want to make sure that I can punch the right thing in. So I know that the third root of 8 is always going to be 2. That's kind of my go-to to see if I have it right. So the way that we use this calculator, I say I want to find, of 8, I want to find the third root, and I get 2. So the way that some calculators you have to punch in, you have to put in the radicand, so 8, and then you need to press the button x root y. And then you have to type in what the root is. Okay, so in this case, I'm going to hit 8, and then I'm going to hit this button. Sometimes you have to use the second or shift. And root 4. So now I use the cubed root of 8 as an example so that I can see if my methodology is right. So if you can find that, go ahead and use it. So if I want to do this type of a question, so note if the radicals have different indices, you can use a calculator to find the approximate values of each. Now in the first one we made mixed radicals into entire radicals. Well, that won't be helpful in this because we're kind of comparing apples and oranges. We're comparing fourth roots to square roots to cubed roots. So really we just need to have those decimal approximations. So if I were to use the calculator, I would do this process and then I would multiply it by 3 to get 3 times the fourth root of 8. So remember, I'm going to start with the radicand, 8, and then I'm going to use the button. This button here, 8, the radicand of 8, and we want to find the fourth root of it. Hit that. I'm going to multiply that by 3. Now that is 5.05. So this first one is 5.05. Now let's find out what the other ones are. So if I wanted to, I'm going to hit the shift button again, so that's normal. If I wanted to find the square root of 2, so 2 square root times 4 equals 5.66. And then the last one, I'm going to say, okay, the radicand of 5, and we want to find the third root of it. Get that, and I need to multiply it by the coefficient of 3 times 3. So it's 5.13. So if I were to answer this from greatest to least, I would say this one first, and then this one second, and this one third. But I'm not going to write the answer as, 5.66, because the question itself states it as 4 root 2. So if I were to put my final answer, I need to use the question or the numbers that were in the original question. So 4 root 2, comma, 3 times the third root of 5, and then the smallest one is going to be 3 times the fourth root of 8.